All right, guys, so we're going to take a look at applications of sine and cosine law when to use each of them. Okay, so um, the first one here is sine law. Okay, and this is just a series of ratios. Okay, so it's basically, it doesn't actually matter if you write this with the sine, the angle on top, or the side length on the bottom, or vice versa. So it doesn't actually matter if I do this. Okay, either one of these will give you the same answer. Okay, as long as you plug in the correct information. Oops. Okay, so with this now, you can use sine law with triangles that don't have a 90-degree angle in them. Okay, and your goal is to actually be able to use this. You want to use sine law preferentially over cosine law. Okay, so if you're provided with the sufficient amount of information to use sine law, you're going to use it. Okay, and there are a few different scenarios. As you go through them, you'll figure out when to use which, but one of them is when you have well, anytime you have, like, let's say two angles and one side length. Okay, so you could have side angle angle. Another one could be a side angle. Okay, things like this. Okay, anytime you're provided with three of the four things. Okay, so if you're provided with three of the four, then you can find the fourth. Okay, Cosine's law is a little bit different, right? It's a little bit, it looks more challenging, but really it's just plugging in information. Okay, now the other thing you can do here is sometimes, obviously with triangles, you can solve for side lengths and you can solve for angles, right? So this particular equation, or cosine law, the way it's written right now is written in a way that allows you to solve for the side length. Okay, if you would like to solve for the angle is going to be right here. You're going to have to rearrange this equation. Okay, it's just like a linear equation. You're going to have to rearrange it to solve for, well, all of cosine A. Okay, so that's what I'll do here. That's all I'm doing, actually. So a lot of people get confused or like freaked out about how to switch between the two, right? But all I'm going to do is move everything else aside from this. So I'm going to move this to the other side of the equal sign and just get this by itself. Okay, that's all I'm doing. Okay, and you'll see here that cosine C is equal to c squared minus a squared minus b squared, all divided by negative 2ab. Okay, and then cosine of b is going to equal, it's the exact same thing, right? Except the variables are different, in different order anyway. B squared minus a squared minus c squared, all divided by negative 2ac. Okay, and the last one, cosine A, is going to equal a squared minus b squared minus c squared, all divided by negative 2bc. Okay, now the way I've memorized this, right, because to use this, all of these cosine laws, if you look at the first and last variable in all of these, the angle and the side length of that are the same kind of sandwich the entire cosine law, right? So, and then you fill in the middle of everything else, so it's the opposite. So if I use C, then A and B fill in the middle. If I use B on the ends, A and C fill in the middle. And if the last one would just be, if I use A, then B and C are going to fill in the middle. Okay, that's how I memorize this. Okay, that way I'm not relying on a formula sheet or anything, right? I'm able just to do, I can do it on the fly, right, and quickly. Now, when to use this one? Okay, you use cosine law when you don't have three pieces of information, okay, in sine law. Okay, So an example of that would be, let's say I'm given a triangle where I'm given each of the side lengths, but I'm not provided any information about the angles, okay? In that instance, I have to use the equation that has all side lengths in it in order to find the angle, one of them. Once you have it, then you can use sine law afterward. So typically you're only going to use cosine law once to find one piece of information, like let's say an angle, and now you're going to have some like what I call brother-sister pairs, right? So you're going to have like an angle and a side length, and then I'm going to be able to use this side length here to solve for this angle in sine law, okay? So that's one of them. So I'll label that as being like, that's side, side, side. We use cosine law, okay? And the famous one, okay, the famous one here is if you have a triangle in which you have a side, an angle, and a side. I call this, or we call this, I didn't name this, this is what we call cos law sandwich. How do you spell sandwich? Oh. Okay, and it's a sandwich because I have, here's my bun, here's another bun, and then I have something in the middle, an angle, okay? So we call that a cos law sandwich. You have to use cosine law in this instance, okay? So let's go down here. We'll take a look at this first example. And again, I emphasized, or I tried to emphasize, the importance of pictures when solving word problems, right? Especially like word problems. The financial questions are a little bit trickier to draw pictures for, obviously, but things in the real world are, you're always going to want to draw a picture. Step 1 is going to be your picture, and then step 2 is list your knowns and unknowns from that picture, and then step 3 would be like pick an equation, okay? So 3 towns. Let's draw a picture here. So we can draw town A, town B, and town C, okay? And we'll just draw a triangle around that, okay? They're located so that town B is 25 kilometers from town A, okay? And C is 34 kilometers from A, okay? If the angle is 110 at city A or town A, okay, calculate the distance from B to C. Okay, so this is what I want to know. We'll call this X or something. Okay, that way we know. So now you have your picture. Okay, you know that. Remember, this is going to be, if this is big C here, then this is little c, right? And this is going to be little b, and we'll leave a as x, okay? Just so we know what we're solving for. So I want to solve for little c is going to be equal to 25 kilometers. Little b is going to equal to 34 kilometers, okay? And then I want to know what x is, okay? But I also know what angle A is. It's 110 degrees, okay? So I know, and you know, because I've explained it to you, that this looks like a cos law sandwich, right? Where I got the side lengths containing an angle in the middle. Okay, so I know I'm going to use cosine law in this question, right? So your job here is, and remember, x is like going to be little a. So if I want to solve for little a, right, I know that I'm going to use cosine law, but which version of it is the question? Okay, well, I need to solve for a, or what we'll call x in this question, right? Okay, So it's always a squared, and then what did I say? The a's contain the entire cosine law, so it's cos a at the very end, okay? And then we fill in the middle, b squared plus c squared. This looks kind of like a Pythagorean theorem, okay? But not quite. And then it's minus 2bc, right? I know it's bc because those are the two in the middle, right? And then that's multiplied against, you could put it in brackets if you like, cosine a. Okay, and then all you have to do is fill in the information that you've written down, right? So a squared is going to equal 34 squared plus 25 squared minus 2 multiplied by 34 by 25, and then multiplied by the cosine of 110. Okay. Then we can just start doing some math. Okay. You could go, well, you're going to go to your calculator and you're going to go 34 times 34. Okay, that's 1,156 plus 25 squared. 25 times 25, 625, right? Minus, okay, we're going to go 34 times 25 times 2, 1,700. Okay, and then that has to be 1,700 multiplied by the cosine of 110. Okay, so we're almost there. We can collect some stuff here. We can go 1156 plus 625. Okay, that's going to be 1,781 now. And then what you can do, we have to do the cosine. Sorry, hold on. We're going to put the number in first. So you're going to go 110 cosine. Okay, and then take that number and multiply it by 1,700. Right, that's where that's coming from. So we're going to multiply by 1,700 times 1,700. So we're going to get minus, and then we get a negative number, negative 581.43. Almost there. So we can go 17. Now we're going to add here, right? Because two negatives make a positive, right? So we're going to go 1781 plus 581.43. Oops. Okay, we're going to get 2,362.43. And then all we have left to do is square root both sides. The square root of 2,362.43. We can square root that. 48.6. Okay. So once you have that, it's in kilometers, we can finish this question. So therefore, the distance between city, we'll call it town, they called it town, town B and C is 48.6 kilometers. Okay, that's it. Now, this, let's say we wanted to solve for other things, like it asked me for the angle between them. You could then therefore go back and use sine law, right? No problem. You can see why you only want to do this maybe once per question, if you can, right? In this case, it just happened to be that the thing I was looking for, I could solve for in one step using cosine law. It might not be that all the time, right? Like you might get some compound triangles that you might have to use cosine law once to get a piece of information to then use it in sine law somewhere else to get your final answer. Okay, might be two-step questions. This one was nice because it was just a one-step, although we still did have to use cosine law. Okay, you'll see in the next question what I'm talking about, and you've seen sine law, right, in practice. You want to use sine law, okay? And I'll do a little check order at the bottom of this as the order in which you want to use things, okay? So let's go down here to the next question. So the largest crater is in North Arizona. It's approximately 1.5 kilometers wide. From one side of the crater, a weather plane is spotted with an angle of elevation of 45 degrees from the opposite side of the crater. The angle of elevation to the plane is 64 from the other side, right? Calculate the distances from the plane to each side of the crater. Okay, so again, we're going to come up with our picture. Okay, so we've got this kind of like crater, right, on the ground. We'll say it's the craters from here to here. Okay, and it's saying that it's 1.5 kilometers wide. Okay, now from one side of the crater, a weather plane is spotted with an angle of elevation of 45 degrees. Okay, so let's say the plane is like flying up here somewhere. Okay, here's the plane. So we're going to have an angle of elevation to that of 45 degrees. And then over here, on the opposite side of the crater, I have an angle of elevation of 64 degrees. Okay, and your job here is to figure out how far is the plane. Okay, let's say there's a person standing here and a person standing here, right? Your job is to say, okay, well, how far is the plane from each of these people? That's your job. Okay, so we can label this triangle in a way that makes sense to us, okay, that we can actually use sine and cosine law, right? So let's say A is up here, B can be down here, and C can be there. Okay, now I can make a list. I can find angle A, okay? Not that it really matters, I can find that using my 180 rule, right? But I know little a, right? This is little a, this is going to be little b, and this is going to be little c. These are the two things I want to know, right? And so a, little a, is going to equal 1.5. Angle b is 45, and it was 45 because it said angle of elevation. That's how elevation was that I knew it went up, right? And also right here, I knew the other side was 64 because it was angle of elevation versus depression. Right? So, and then I finally know angle C is 64 degrees. Okay? So, we can go ahead now and solve for these two side lengths. This is what I need. Okay? Now, which one do I use? Well, I have two angles available to me. Okay? And if I look at cosine law, okay, anywhere in cosine law, it doesn't matter which one you look at, I only have one angle. Okay, so that should be a clue, okay, that I'm being pushed in the sine law direction, right? The other thing you have here is you have a side angle angle, right? So there's your side, there's your angle. So we're going to use sine law in this question, and you can always write sine law out, right? Because your goal is to use sine law first, right? So you're going to write it out and see if it works. If it doesn't work, then you have to use cosine law, right? But 9 times out of 10, I shouldn't say 9 times out of 10, maybe you get lucky, okay, and sine law works and you don't have to use cosine law. It's probably not going to be 9 times out of 10, okay? But always try sine law and see if you can use it, because you want to use it over cosine law, right? So I'm just going to write it out here. So it's sine A over A. And again, it doesn't matter if this is in the top or bottom. It doesn't matter. This is just the order I've gotten used to writing it in. B over B sine C over C. Okay, so we can start filling in information. 45 is angle B, so we can go sine of 45 over B. I don't know what it is, okay. Is equal to, let's use angle or side length A. We have to use side length A for sure, okay. So this is going to be 1.5, okay, and sine A. Now here's the problem. This gets back to what I was talking about earlier, okay. When I said we could find angle A, okay, I only have two pieces of information at the moment, right? Like I'm missing this and I'm missing this, right? But I have this and I have this. So you need 3 out of the 4 in order to do anything, okay? So what you're going to have to do here is use your 180 rule for triangles, okay, to find one of the side lengths, okay? So what you can do, or sorry, your 180 rule to solve for angle A. Okay, so you can go 180 minus, because they have to add the 180, minus 45 minus 64. Okay, and then from there, that's going to tell you what angle A is. Okay, and once we have angle A, then we've unlocked everything that we need to unlock. Okay, so it's 180 minus 45 minus 64, 71. So angle A is equal to 71 degrees. Okay, now you can plug that in. We can get rid of the A and we can go 71. Now from here, you need to solve for this. So what you do is we do what we call cross multiplying to get rid of fractions or ratios, right? And so I'm going to get B sine 71 is equal to 1.5 sine 45. Okay. And then from there, I need to get B by itself, so I can divide both sides by sine 71. Okay, so B is equal to 1.5 times sine of 45 over sine of 71. Okay, and then these are just, this is just a calculator exercise now, right? We're going to type in 45 sine, okay, where's sine here? Am I missing it? No, there it is. So it's 1.5 multiplied by 0.7 divided by 0. What did I just put in? Yeah. Okay, and then 71 I gotta do, we'll do the sine of 71, 0.94. Okay, so B is equal to 1.5 times 0.7. Okay, divided by 0.94. We call it 1.12 kilometers. Okay, so that means that the distance between the plane observer, B, so sorry, C is 1.12 kilometers. Okay, now that's just one of the observers, right? And now some of you might say, okay, well, now this is great. Now I can use C squared equals A squared plus B squared now to get the other one. Okay, you can't do that. because there's no 90-degree angle here. Remember, this is only for 90-degree triangles. Okay, so we can't use that. Okay, so what you're stuck doing is just sine law again. Okay, so but this time you now know more information, right? So I can fill in the fact that this is 1.12 kilometers, and now I can pick information. I know I have to use sine c over c somewhere, right? So I know I have to do sine c over c is equal to, but I can pick anything else that I want. Okay, I'm going to use a over a because it was the information provided in the question, right? So if I made a mistake here, okay, then it's not going to carry through the question. So I'm going to go sine a over a, okay, because a is the information provided. So what we can do now, I'll leave this in red, keep this work separate from the work in the black, okay? We can go sine of c is going to be 64, so sine of 64 over c is what I want to know, okay? And then sine of a was 71 over 1.5, okay? And now we can go little c is equal to 1.5 multiplied by sine 64 over well, I'll do this here just so you guys can see what's going on. Okay, I cross multiplied and got rid of the fractions. Okay, and then now I'm going to divide both sides by sine 71. Okay, and so c is equal to 1.5 multiplied by sine 64 over sine 71. And now I get to just type this stuff into my calculator. So you remember sine 64 is going to be we'll call that 0.9. So it's 1.5 multiplied by 0.9 divided by 71 sine 0.95. Okay, and then we just type this in our calculator. 1.5 multiplied by 0.9 is that, and then divide that by 0.95. 1.42. Okay, so therefore the distance between the plane observer, whatever that will be, is 1.42 kilometers. Okay, now I'm going to try and go down here for a sec. I'm going to add a page just to give you a little checklist with your trig stuff. Okay, so I'm going to go all the way down here. Okay, and I'm going to write an order of things that you want to check first. Okay, so we'll go we'll call it trig preference list. Preference list. Okay, first thing you want to check for is right angle. Is a right angle present? Okay, if there is, then you get to use the first thing you want to check. I guess this will be the question, and then the first thing you want to use or check for is okay, that's what you want to check for. You want to, so this is like c squared is equal to a squared plus b squared. Okay, if you can use that. Okay, and the second thing, I suppose you can also use your 180-degree rule. I guess these are interchangeable. Okay, from there, your third thing that you want to use is, and you're wanting to use Pythagorean theorem over SOHCAHTOA. Okay, and notice I'm only writing these things under the right angle. Okay, from there, the next thing you're going to want to do, okay, is, okay, well, if there's no right angle present, now I'm stuck using sine no right angle, then you're kind of stuck using sine law. Okay, and if sine law doesn't work, then your last resort, which should always work, is cosine law. Okay, so cosine law is your friend, although being very ugly. Okay, it can solve most of the questions, or all of the triangles that you can that are put in front of you. But you saw how labor intensive it was, right? I don't want to do that every time. Okay, so there's lots of questions here for you guys to practice on. There's some compound triangles I was talking about before. So these are examples of you might need sine and cosine law in order to solve for something else, in order to actually answer your question of, let's say, what angle B is or something. Okay, that's it. You guys can let me know if you have any questions. Hopefully you found this preference list helpful as well. Okay, so let me know if you have any questions.